Hello, chemists. It's Mr. Mathis again, down in the basement. Going to teach you a little bit about concentration today. We've already learned this. This is just a review. The next lesson will be more about new stuff, but this one is just review for things you've done before. So let's look at this first one. It says, "How many moles?" So there's our question right there. Circling that. Are in 451 cubic centimeters of an aqueous solution of NaOH with a concentration of 2.41 moles per cubic decimeter. Okay, so this question, we're given 451 centimeters cubed. Remember, centimeters cubed, we always need to turn into decimeters cubed by dividing by 1,000. So we would say 0.451 decimeters cubed. So I'm going to write that down. We have 0.451 decimeters cubed of NaOH. Okay, that's what we have. What we want to know is moles of NaOH. Now we could do this a couple of ways. One, we have that equation we've used before. Concentration is moles over volume. Valid, reasonable to use that. However, it's probably better to use our mole roadmap because our mole roadmap has this information on it. If we go to our mole roadmap here, we're starting out with the volume of solution right here, right? And we want to know moles. So what we're going to do is we're going to multiply by the concentration over 1 cubic decimeter, okay? So we all clear on that? We're here, we want to go here. This is what we have to do, concentration over 1 decimeter cubed. So what I'm going to do is I'm going to take the concentration, 2.41 moles over 1 cubic decimeter. Okay, that allows us to cancel out these cubic decimeters, and what we're left with is moles of NaOH, which is what we want. Okay, so we pull up the calculator and we say 0.451 times 2.41 divided by 1. And it gives us 1.0869, 3 sig figs. We just say 1.09 moles of NaOH. Okay, so that's our moles of NaOH. Let's try another one. This one says, what is the volume of an NaOH solution with a concentration of 2.1 moles per cubic decimeter that contains 60 grams of NaOH? All right, for this one, we would start by putting what we know, 60 grams of NaOH. All right, so how would that work on our mole roadmap? Well, now, here I'm going to erase what we've got already. Right. We are at mass in grams. We want to get to volume of solution. So we're going to go in here, and then we're going to go out through there. So basically, we're going to do the 1 mole over the molar mass. And then remember, there's this mole ratio in here. But since we're talking about NaOH and NaOH, the mole ratio is just 1 over 1. I'll put it in there. It's not really useful, but I'll put it in there anyway just so we can see that the mole ratio is always used. It's just sometimes not going to do anything. Okay, so we've got 60 grams of NaOH. Na is 22.99 plus 16 for oxygen plus 1.01, which gives us a total of 40.00. So we say times 1 mole over 40.00 grams. So now we've got from grams to moles, all right, but our goal is to get volume. So now we're going to, we've got 1 NaOH and our mole ratio is 1 NaOH. They cancel out. Nothing happens. Okay, you don't need to do this if you're just doing one substance. It's only when you're doing 2 different substances do you need that mole ratio. Okay, and then we will times, and see what it says here. We have to go 1 decimeter cubed over the concentration. Okay, so we're going to put 1 decimeter cubed on top over 2.1 mole on the bottom. See, we flipped it over, the opposite of what we did on the last problem. Okay, so calculator, whoops, calculator, 60 times 1 over 40 times 1 over 1 times, we've got 1 over 2.1. So we're going to take 1 over 2.1. And that gives us 0.714. So basically that would be 0.714. And you can see how, here's what happens to our units. We're left with decimeters cubed of NaOH solution. Okay. All right. We'll do one more different problem. This says, how many grams of NaOH would you need to make 300, oops, I don't like that. I'm going to underline 300 centimeters cubed of a 5.6 decimeter, moles per decimeter cubed solution. Okay, so for this one, we're doing the opposite of what we did last time. Okay, last time we were going from mass to volume. Now we're going to go from volume out to mass like this. We're going to follow that path. Okay. So we've got 300. Ooh, this is centimeters cubed, right? So we have to divide that by 1,000 to turn it into decimeters cubed. So we've got 300. So we're going to say 0.300, right? Because 300 divided by 1,000 is 0.300 decimeters cubed of NaOH, right? And our goal is grams of NaOH. So we say times, we multiply by our concentration, 5.6 moles over 1 decimeter cubed. So that cancels that out. Now, as I said before, we have the mole ratio here. We can do it because we're leaving moles. But of course, the 1 NaOH over 1 NaOH just cancels out. Finally, we are going from moles to grams. So we're going to use our 40.00 grams for every 1 mole. Okay, that cancels out our moles. And now we have grams of NaOH, which is exactly what we're looking for. Okay, let's put it in the calculator. 0.300 times our concentration, 5.6 over 1, times 1 over 1, which is just our NaOH over NaOH, times 40.00. That's our grams divided by 1. So we get 67.2 grams of NaOH. Okay. Now, again, this is all review. This is all stuff we've done before. The next lesson will be about new things. Okay.